Hello everyone, welcome to our class number 4. So we have been doing some classes altogether, I have completed 3 classes by now. This is the 4th class where I'm planning to teach some object-oriented programming that can be used for numerical analysis and data science or any sort of an analysis. In addition to object-oriented programming, I will be doing some string manipulation examples today. So this is the class number 4. So this is the class number 4. So the topics I'm covering today is object-oriented programming, and string manipulation. String. Okay, so let's begin with object-oriented programming. Um, this can be a little hard at first to understand, but once you get the hang of it, it will be easy for you to apply this object-oriented programming, or sometimes called OO programming, um, to apply for the problem of interest. So let me try to uh, bring the idea with an example. So let's say we have a car. Let's say we have a car, and what actually defines this car? In other words, what are the variables that will define this attributes of the car? Like variables, let's say, like for a person to understand or identify what this car is, that person may need the year of manufacturing. Like, when was this car manufactured? And it certainly helps the model of the car. Or the year is known, model is known, then it's easy for us to understand what this car is. Maybe mileage, so how far this has run. So let's say these 3 variables, year, model, and mileage, define the car. So we can identify this car as an object. Then that object is identified through these variables. And once they are identified, we know what the car is, and then we can actually like put the car to undergo methods. We can apply methods on the car. Like we can accelerate, or we can brake, for example. So we we use this car example to bring about an example in the object-oriented programming. So let's say, now let's summarize what is written here. So our class is car. Then class and variables. What are the variables? Year, model, and mileage. And then methods. Accelerate and brake, or braking. So the object car has three variables and it has uh, two methods. So let's see how we can put that into practice in the Colab Python. Let me call this the example one. Well, one. So our class object is car. Under the class car, we write the following codes. We define the variables, define double underscores, 1, 2, init, I-N-I-T, again double underscores. Within brackets, we write self, comma, then the variables. What are the variables? Variables of the car. Year, comma, model, comma, mileage. Under that, we actually assign the variables to the car. It is done. It is done in the way I'm about to write here. Self dot. Let me say car year equals year. Self dot car model self dot car mileage So what this does is this assigns this variable values to these variables. Okay. Then methods. We write methods. So define like methods are written in the function format. We define those functions. Define accelerate. We define the accelerate function. Accelerate self. Return. For example, let me write return accelerating. Next, we define the brake. function, breaking. So let me return breaking. Okay. Now we run the code. Now it has run. Now let us see how we can apply this class object on some application. Let's say my car one. Let's say I have a car called car one is equal to. Now we define this object by writing what that object is like. This class object is car. So we define this variable by writing that it's a it's a car object, and we write the variables. Let's say the car I have was manufactured in 1965, and its model is let's say Ferrari, and the mileage it has run is 90,000. Okay, 90,000. We can run the code. Now the car one is defined to be a car made in 1965. The model is Ferrari. Mileage is 90,000. So once the variables are assigned, we know that it's a car, and we can apply methods on this class, this car one. So let us apply a method and print it. Print. What method we are going to apply? Say we put the car to undergo the accelerate function. Accelerate. According to our definition of the accelerate function, it should return the string accelerating. Let us see. See, it has returned the accelerating string. Now let us put the car one to undergo braking function. Now, according to our definition here, it should return the string braking. Okay, braking. So this may look simple at first, but believe me, this method can be applied to like many examples. There are many applications for this object-oriented programming, defining class objects. So one major example I have come across in my life is for the application of object-oriented programming, the use of evolutionary algorithms like genetic algorithm, simulated annealing, and colony optimization. So these algorithms have like individuals. Let's say in the genetic algorithms, there are individuals to whom we need to assign a genetic code. So the variables become the genetic code. And the methods, there are many methods we have to apply. Like we have to evaluate the fitness, we have to evaluate the cost, some algorithms like particle swarm optimization. It has, in that we have to assign speed of the particles in that for that particles. So there are many methods we have to assign to those objects. So object-oriented programming may have many other applications that I'm not aware of. So, but it's better to learn this now and find out the applications later on. So like I said, we can have a look at our example number 2, where I'm going to explain to you some simple, like how to apply this OO programming for algorithms like genetic algorithm. So let me clear my drawings here first. Say we have, say there is an individual, he or she. According to Darwin's theory of evolution, the characteristics of this person is like they come from the genetic code. Like if this is the genetic code of that person, and let's say it has 2 variables. Let's say G1 is the first variable, G2 is the second variable. The genetic code or the genome is a string that defines the characteristics. So this is, let's say, this is a human, he or she. In the object-oriented programming, we can define this person in the class object. So the class is human. Variables are G1 and G2. Let's say we can, the human can undergo many methods. Methods like evaluate fitness, let's say get fitness, or get, let's say, speed. For now, we will focus just on these 2 methods. So we have a human whose variables or the genetic code is defined by 2 variables, G1 and G2, and it can undergo methods like fitness evaluation and speed evaluation. Okay. So the, let's say, get fit, like fitness function, get fitness. This method is defined by, let's say, fitness is a function of the genetic code. So once the variables G1 and G2 are assigned, those are the variables that will define the fitness function. And right, those are the variables of the fitness function. So let's say fitness function is a function of G1 and G2. G1 and G2. Let's say it is 100 minus G1 square minus G2 square. Let's say the speed function is also a function of the genetic variables G1 and G2. Let's say it is the function is G1 plus 2G2 plus G2 squared plus 20. Okay. Now we can write the code for this. Now first we need to define the class human. Define double underscore init double underscore what self. What are the variables? G1 comma G2. Self. Now we assign this variable to the class object variables like self.g1. Let me say g1 is equal to g1. Self.g2 is equal to g2. Now when defining functions, we use these as the variables, not g1. Not just g1, we write self.g1 and self.g2. So let me show you how it's done. Now we define the methods, method functions, get fitness, define get fitness, self, return. What is the fitness function? Now you see, this is the fitness function. So we write this here, 100 minus g1 square minus g2 square. 100 minus g1 square minus g2 square, g2 square. But wait, now I just told you we don't use just the variables for defining the method functions. We write these ones because the g1 is assigned to this self.g1. So we write here self.g1 and self.g2. Self.g2. Okay. Now define get speed function. Speed self we want to return the value of the speed function. So this is the speed function, g1 plus 2g2 plus g2 square plus 20. So we write it. Instead of g1, we write self.g1. Self.g1 plus 2g2. 2 multiplied by self.g2. G2 square, which means self.g2 square Okay. G2 square plus 20. Here the class has to be a word where all the letters are simple. Class human. Okay. Now that is fine. It is fine. Okay, the object is fine. Now we can define a real object. Let's say as these objects are humans, we can define humans by this method. So let me define a person named Rajita, and Rajita is a human. By the way, Rajita is my name, and Rajita is a human whose genetic code has variables like G1 equals G1 equals 1.5, G2 equals 0. Rajita, G1 equals 1.5, G2 equals 0. Now, the variables are G1 and G2 that are equal to 1.5 and 0 respectively. And we can run the code to define the person Rajita. Now the person is defined. Now we can evaluate the fitness of Rajita. So we can print. So we make Rajita to undergo the fitness method. Get fitness. So based on the genetic code, this genetic code 1.5 and 0, Rajita has a specific fitness value. So let's see what Rajita's fitness is. It's 97.75, whichever the unit it is. Print Rajita dot get speed. Let's see Rajita's speed. What Rajita's speed is? It's 21.5. So this way we can actually code a genetic code of like many variables, not just two, let's say 8, 10, probably 1,000, 10,000 variables. It is possible to do this. So this is the basic way we can actually code some objects into the class objects, and we will find many applications in evolutionary algorithms like genetic algorithms and particle swarm algorithms, and probably many other algorithms as well. The algorithms that I'm not aware of. It's better to learn this thing, and as we go, we can see some other applications as well. So, yeah, this is a basic introduction to OO programming.